Hey guys, this is Mrs. Harbin, and this is the presentation for Algebra 2, Section 1.8, Absolute Value Equations. Our biblical application for today is this. God is concerned about numbers. He created them for our use to help us be organized and orderly. Because He created them for us to use, we need to know how to use them. That's why He created them. So let's make sure we know how to use all of these numbers and use them in a way that's applicable, organized, and orderly, the way God intended. Our lesson objective for today is this. You, the student, will solve absolute value equations and write absolute value equations describing graphs. So when we're talking about distance and we're talking about location of different things, both distance and direction are needed to describe an object's position relative to a fixed reference point. Hey, take me, for example. If I'm here at home right now and I'm trying to describe where you are located, I would need to know two different things. I would need to know how far away you are and which direction to head. So I might say that you are 5 miles to the northeast, or maybe you're 10 miles to the west of me. We need both distance and direction. When you plug in an address on your GPS gives you those things. They tell you how far to go and then to turn left or right or head north or south. So GPS gives you distance and direction. When we're talking about the number line and then eventually the Cartesian plane, we need to know both distance and direction relative to a fixed reference point. We've got to have a starting point. And on our number line, that starting point is 0, or the origin. The distance is from the origin, and our direction is not north, south, east, or west, but our direction is to the right. That's where positive values move us, or to the left. Negative values move us left on the number line. And those are the only two directions on the number line, but they all start from that origin, that 0 point. When we're talking about absolute value, we're using this symbol right here, these absolute value bars. And this is read as the absolute value of x equals 3. And it can be interpreted as x is 3 units from 0 on the number line, or x is 3 units from the origin on the number line. Absolute value basically tells us how far away from 0 a number is on a number line. And there are two possible values. We know that -3 is 3 spots away from the origin, and 3 is 3 spots away from the origin, or 3 units away. So there are two possible values when we're talking about absolute value. X must be either -3 or 3. The graph of the absolute value of 3 looks like this. We've got a dot over here at the -3 and a dot here at the 3. And those are my two possible values. Those are both digits that have an absolute value of 3 that are 3 spots away from 0. 1, 2, 3. And 1, 2, 3. So absolute value can look like this. We have the absolute value of x equals, it equals just x if x is greater than or equal to 0. It equals -x if x is less than 0. Let's put some numbers with this. Let's solve x plus 5 equals 9. So we've got these steps over here to the right on how to solve an absolute value equation. Our first step says make two problems. Our second step says simplify, and our third step says solve. So let's see what that looks like. Well, first of all, we know that there are two possible answers. You just saw that on our graph of a number line, that in absolute value, there's the distance, the one on one side of the origin and one on the other side of the origin. So we know that there are two possible things that have an absolute value of 9. We know that 9 has an absolute value of 9, and -9 has an absolute value of 9. So the first thing I'm going to do is write this as two equations, one equal to the positive 9 and one equal to the -9. After I've done that, I'm going to follow my steps of algebra to simplify and solve for x. And I find out that x equals either 4 or -14. If I were to plug both of those back into the equation, both of those numbers would get me something that has an absolute value of 9, which is where we started. The absolute value quantity must be isolated on one side of the equation before the absolute value equation can be rewritten as a disjunction of two equations. So let's take a look at this. Right now, my absolute value equation is not isolated. It's got a minus 8 and a times 2 on the same side. We've got to isolate that absolute value equation first before we can do the following steps. So first, let's add 8 to eliminate the 8 here. And whatever we do on one side to keep it balanced, we need to do on the other side. My next step is to divide by 2 to eliminate the times 2 here. And whatever we do on one side, we do to the other. That gets us the absolute value of 3x minus 12 equals 16. Now we can go on to step 2. Make two problems. 3x minus 12 equals 16, or 3x minus 12 equals negative 16. We can then simplify using our steps that we've learned in algebra. And we get that x is equal to 28/3, or x is equal to negative 4/3. We want to plug this back into our original equation, substitute this back in to make sure that that actually works within that equation. The absolute value of an expression, because it's always the distance away from something, is never negative. You can't be negative distance. The absolute value is always written as a positive. Recognizing this will allow you to quickly determine that there is no solution to an equation. So let's take a look at this example. First, we need to isolate the absolute value. Check. It's already been isolated. So let's write it as two equations. 2x plus 9 equals 3 minus 8x, or 2x plus 9 equals, and then we're going to apply that negative sign to everything on the right-hand side. When we solve for x on the left, we get x equals negative 3/5. When we distribute this negative sign and then solve for x on the right, we get x equals 2. When we plug these back into the original equation, negative 3/5 checks out. It works. But when we plug 2 back into the original equation, it doesn't work. Let's take a look. I'm going to write the original equation here. Absolute value of 2 times 2 plus 9 equals 3 minus 8 times 2. That gives us the absolute value of 4 plus 9 is 13 equals 3 minus 16, negative 13. We just said the absolute value cannot equal a negative number. What's inside can be negative, but what's out here cannot be. So there is no solution. That does not check out. We call that an extraneous solution. An extraneous solution is invalid because it does not make the original equation true. And you can sometimes have extraneous solutions. So you need to check your work by plugging that number back into the original equation through substitution and plugging and chugging to make sure it works. Let's talk a little bit about distance on the number line. The distance between 2 points is the absolute value of the difference of their coordinates. Difference just means subtract. So we're going to subtract our two coordinates and take the absolute value of that amount. It's written this way: the distance equals the absolute value of b minus a. The midpoint between a and b, which is a coordinate, is the average of the endpoint's coordinates. Well, to find the average of something, we add all of our units up and we divide by the total number of units. In this case, when we're talking about the distance of 2 points, we're going to add our 2 points up and divide by 2. Let's take a look at an example. Writing an absolute value equation representing the graph. Now, first of all, let's talk about the distance. We said the distance is the two values. We subtract those two values and we do the absolute value of that difference. So we're going to take 5 minus negative 1. See if you can figure out the distance on your own. We'll check it in just a moment. To find the midpoint, we take the two endpoints, 5 and negative 1, add those together and divide by 2. See if you can find the midpoint on your own. All right, here's our formula for midpoint. Negative 1 plus 5 divided by 2, which gives us a midpoint of 4/2, which simplifies down to 2. And our distance is 5. That's not what that should say. Our distance is 5 minus negative 1. 5 minus negative 1. Let's write that here. 5 minus negative 1, which is the absolute value of 5 plus 1, which is 6. And if we look up here, 1, 2, 3, 4, 5, 6. It is, in fact, 6 spots away. Now, this is the distance from the midpoint. So each of our endpoints is 3 away from the midpoint, but the total distance is actually 6. If we wanted to write an equation, we're going to use the midpoint and the distance from the midpoint plugged into this equation. X minus the midpoint equals, I'm going to put a dm to signify distance from the midpoint, not the total distance. Today, we worked on these things. We solved absolute value equations and wrote absolute value equations describing graphs. We went through that last one really quickly. If you need help with that or anything else, be sure to ask me in class.